Deep Dive, Sliding Window Algorithm for Rate Limiting. The sliding window algorithm is an advanced rate limiting technique that addresses limitations of simpler methods like fixed window. It ensures smoother traffic control by dynamically recalculating request limits within a real-time sliding window. 1. How it works. 1. Sliding time window. Instead of fixed intervals, the algorithm uses a rolling window of time, e.g., 1 minute, that continuously moves forward. 2. Request tracking. Each incoming request is timestamped and stored in a data structure, such as a queue or list. The timestamps help track the number of requests within the current window. 3. Real-time adjustment. Requests older than the sliding window duration are removed, ensuring only valid timestamps within the window are counted. 4. Request validation. If the number of requests in the current window is below the defined limit, the request is allowed. If the limit is exceeded, the request is denied. 2. Key characteristics. Dynamic adjustment. The window continuously slides forward, enabling real-time recalculations. Traffic smoothing. By avoiding rigid boundaries, it ensures even distribution of requests over time. Fairness. Requests are handled based on actual activity within the current window. 3. Advantages. 1. Smoother traffic control. Prevents spikes caused by window boundaries, unlike fixed window. 2. Fairer distribution. Requests are processed in real time, making it suitable for applications with variable traffic patterns. 3. Greater flexibility. Works well in systems where consistent traffic flow is essential, such as critical APIs. Limitations. 1. Increased complexity. Sliding window requires maintaining timestamps for each request, making it computationally more expensive. 2. Higher resource usage. The algorithm demands more memory and processing power to manage timestamps, especially for high-traffic systems. 3. Concurrency challenges. Handling simultaneous requests requires careful synchronization or distributed solutions like Redis. Practical scenarios. The sliding window algorithm is ideal for high-traffic APIs, ensures smooth handling of large-scale traffic without abrupt rejections. Fair usage policies, provides more consistent user experience by evenly distributing rate limits. Critical systems, eliminates sudden traffic spikes, ensuring reliability in services like payment gateways or authentication systems. Number 6. Step-by-step process. 1. Initialize tracking. Use a queue or list to store timestamps of requests for each user or IP. 2. Add new requests. When a request arrives, its timestamp is added to the tracking data structure. 3. Remove expired requests. Remove all timestamps older than the sliding window duration, e.g., 1 minute. 4. Count requests. Calculate the number of valid timestamps within the current window. 5. Decision logic. If the request count is below the limit, allow the request and update the tracking data. If the count exceeds the limit, reject the request. Example use case. Imagine a login API where users can make up to 5 requests per second. Every request is timestamped when received. Timestamps older than 1 second are removed from the tracking system. If fewer than 5 timestamps exist in the current 1-second window, the request is allowed. Otherwise, it is denied. Optimization tips. 1. Efficient data structures. Use data structures like queues to minimize processing overhead when adding or removing timestamps. 2. Scalable storage. For distributed systems, store timestamps in a centralized database or caching tool like Redis for consistency. 3. Tune window and limits. Customize the window size and rate limits based on traffic patterns and application requirements. 4. Concurrency management. Implement locking mechanisms or distributed synchronization to handle simultaneous requests. Number 9. Why use sliding window? Fair and smooth. Provides even traffic distribution and avoids spikes caused by rigid window boundaries. Real-time accuracy. Tracks and limits requests dynamically, making it ideal for systems with unpredictable traffic. User-friendly. Reduces the chance of sudden rejections, leading to a better user experience. Chat conclusion. The sliding window algorithm is a powerful rate-limiting solution, ideal for systems that require fairness and smooth traffic control. While it demands more computational resources and complexity than fixed window, its ability to handle real-time traffic and eliminate spikes makes it indispensable for critical applications. With proper implementation and optimization, it ensures robust performance and user satisfaction across high-traffic APIs. Explaining the sliding window algorithm pseudocode. This pseudocode represents how a sliding window rate limiter works to control the number of requests a user or system can make within a specific time window. 1. Understanding the components. 1. Limit. This is the maximum number of requests allowed within the sliding window duration. Example, if limit equals 10, only 10 requests are allowed in the sliding window. 2. Window size. This is the length of the sliding window in seconds. Example, if window size equals 60, we're limiting requests to 10 within a rolling 60-second window. 3. Timestamps. This is a list or queue where the algorithm stores the timestamps of incoming requests. It helps track when each request was made, allowing the limiter to calculate how many requests fall within the current window. The initialization. In the initialize function, the limit and window size are set based on the rate-limiting requirements. The timestamps list, or queue, is initialized as empty to store request times as they arrive. 3. Checking a request. In the isRequestAllowed function, the following steps are performed. Step 1. Remove expired timestamps. Why? The sliding window only considers requests made within the last window size seconds. Any older requests should be removed. Example, if the window is 60 seconds, requests made more than 60 seconds ago are irrelevant. How? A while loop checks the oldest timestamps in the list queue. If a timestamp is older than current time window size, it's removed. Step 2. Check request count. Why? After removing expired timestamps, the length of the remaining list tells us how many valid requests are still in the current sliding window. If the count is below the limit, the new request can be allowed. How? If the list has fewer than limit entries, add the new request's timestamp to the list. Allow the request, return true. If the list already has limit entries, deny the request, return false. 4. Real-life example. Let's say